Thank you everybody for attending the webinar. As Fran stated, this webinar is to cover the top 10 questions on 3D printing. When I was approached with this topic, I have to be honest, I attend so many shows and I get so many questions, and it was hard for me to choose the top 10, but I decided to choose what I feel are probably the best 10 questions to ask and provide the answers for them. And as Fran stated, if you have any questions, just let us know and we'll get back to you with the answers. So let's go and break into it. So the very first question that I receive on a regular basis is, how did Asiga get started? And so on the screen right here, we have two of our very first legacy machines, and that's our Pico and our Pro 1 3D printer. So this is actually kind of where we all began. And so at Asiga, we began in 2007. That's where the concept for Asiga started. And it was actually brought up by a gentleman that he attended a trade show and saw 3D printing in person, was completely blown away by it. And he was like, you know what? I can go ahead and I can go above and beyond this, and I can make something even better. And so in 2011, we launched our very first machine, which is the Pico Plus. It's a cute little machine that looked like a little coffee maker. Actually, it looked like a Keurig coffee maker. And we're revolutionary at that point in time because we were the first 3D printer company to utilize LED DLP technology. And we were the first 3D printer company to utilize printing on a Teflon membrane. And so it was revolutionary because we actually brought two standards into the 3D printing world that we see across so many different platforms today. And so let's go ahead and let's continue on to the next slide. There we go. And so our ultimate goal when we first got started was to design and build reliable, affordable 3D printers that could be manufactured for end-use products right out of the gate. And so it's been an amazing experience, but it all started in 2007. So this just kind of gives a little bit of history on Asiga. If you watch any of my previous presentations with Zahn, you will actually see that we give a little bit of a deeper dive into the history of Asiga, but that's just kind of how we got started initially. And so let's go over to the next question. The next question I get pretty regularly, almost at every show, is what all do I need to incorporate 3D printing in my laboratory or my practice? And so first of all, of course, you're going to need a 3D printer. The next thing that you'll need is some sort of scanning device, whether that's an intraoral scanner or a desktop scanner. You also will need a CAD solution. And so that's either having your own CAD software or outsourcing through a CAD design center. For example, Zahn does have a design center that you can utilize, or if you don't have, or if you don't want to go through and you want to control your own output, then you can have your own design software in-house, of course. You will need a way to wash your prints and a way to cure your prints. And so whenever somebody thinks about 3D printing, they always see the 3D printer, but then they forget about the workflow behind it. And so when we look at the digital workflow for digital dentistry, we have to remember is that it starts somewhere, and that starting point is always with the first patient. From there, it's going to then migrate into capturing the intraoral data, either with an intraoral scanner and then to a CAD design software, or it's going to migrate from the patient to a manual impression and then to pour up a model and then a desktop scanner, for example. From there, everything has to end at a CAD service or design solution and then move into the 3D printing aspect. But after we get to the 3D printing aspect, everything else will remain the same for finishing, and that includes washing the printed parts and then, of course, post-curing the printed parts. So let's dive into the third question. This is a very common question I get because there's so many different varieties of technology used for 3D printing. And this question is, what technology does Asiga use for our 3D printers? And so when we look across the spectrum in dental, there's like polyjet 3D printing, there's stereolithography in the form of laser, LCD, and DLP, and there's many other technologies that we see in 3D printing in general, but the most popular we see today in dental 3D printing is DLP technology. DLP stands for digital light processing, and this is where we use a DLP projector to cure layer after layer to create the structure. So I have a quick little, picture of how this works. For DLP technology, we have our DLP 3D printing process. We have a build platform that's going to move up and down into the liquid resin tank. Below the resin tank, we have a DLP projector, which is then going to project an image to cure a layer, and it's going to cure layer after layer after layer until the printed object is completed. Now, this is pretty standard technology for DLP 3D printing. This is like DLP 3D printing by the definition and by the book. So beyond this, Asiga has some technology advancements that make us unique in who we are and makes us special and separates us from the rest of our competitors. And so the first technology that we have outside of DLP is the way that we monitor our layer formation. And so Asiga has what is called the Smart Positioning System. This is where we use a series of pressure sensors, one on each corner of the basin or where the resin tank goes, and it detects the viscosity of the resin and it prevents deflection, and it analyzes each layer formation to make sure it's reaching the true proper layer thickness. When we look at our competitors, they have an assumed Z resolution or an assumed Z position. And so that means the build platform is going to separate from the layer that it created, and the printer tells it that it needs to reapproach to a particular height. If that printer, and all of our competitors cannot, detect exactly where that, or exactly when it's reaching the true layer thickness, regardless of material viscosity, you'll have essentially an uneven layer thickness. And so with our competitors, you'll see that they have a very wavy surface quality. That's because they have an assumed Z position versus our Asiga Max and Pro 4K, which harnesses the SPS technology. This gives us a known platform position every single layer that is created, giving us a precise layer thickness. And so that's why if you actually go to a trade show, take a look at the printed models at our stand, and then go look at our competitors. You'll actually notice that the surface quality for our printed prosthetics are significantly greater, and it is due to this SPS technology. I have a quick video that kind of explains this, and hopefully it'll help demonstrate why the SPS technology is so great and help you give a better understanding of what technology we use. So this is shown on our Asiga Pro 4K. However, this same thought process and principle is applied on the Asiga Max as well. So on each corner, we have these pressure sensors. They're called position encoders. And what will happen is when the build platform moves down into the resin tank, it has this effect called, or what I call the battle of viscosity. And so what happens is that the build platform is going to move down, and it needs to detect the pressure of the viscosity resin, or the viscous forces, and it needs to know exactly when that pressure has been relieved before we expose the light. So we can see when the encoders are triggered red, that means that the viscous forces are still flowing and it needs to be relieved. Once they turn green, the pressure has been relieved and the light will then expose. This is just the simplest way to explain how the SPS technology works, but essentially we make sure that every layer that the resin has stopped flowing, the deflection is completely eliminated before exposing the layer light itself. Our next technology, this is the final nerdy aspect that we'll go into, is our integrated radiometer. A radiometer is a tool that measures the intensity of light. And so our printers have an internal integrated radiometer that's constantly measuring the light output from the DLP projector to ensure that every layer receives the appropriate dosage of light. So the reason why we have this is because every LED light, it doesn't matter if it's in a projector for a 3D printer, LED lights that are in your house, LED lights that are backlighting your TV, or the LED lights on your computer screen today, each one of those LED lights, they're naturally degrading. They're slowly weakening and becoming weaker over the lifespan of the LED. So as the LED light decreases over time, our printer will automatically adjust the exposure time. So it reads that change in output and it automatically increases that power to ensure that we're always reaching the exact dosage of energy needed to cure that exact material. And as you know, we have over 500 plus materials available to print in our machines. This allows us to create a spectrum of materials and profiles to cure any material. So this LED light radiometer, this internal radiometer, is crucial for the success of being able to ensure that our machine reacts the same in 10 years as it did the first day when you unboxed it. So let's move on to our fourth question. So this fourth question is something that we get quite a bit as well. It is, what is the difference between XY resolution and Z resolution? And so the best way to explain this is that XY resolution is what ultimately determines the precision of a machine. The Z resolution, which is the layer resolution, is how smooth of an object or how smooth of a surface quality we can achieve. And so most printer manufacturers, they should display most definitely XY resolution. That's what you want to look at for defining the precision, but also Z resolution. This is what is controllable on a machine. And so for example, our machines, they have a 1 micron Z resolution that's controllable from 1 micron to 150 or 200 micron layers, for example. And then the XY resolution, this is a fixed number. So let's focus on the XY resolution because that is actually the most important. So on my screen, I have two images. The image on the left is being projected with an 80 micron resolution pixel size. So that's an 80 micron XY precision. And then the image on the right is a 56 micron precision. We can see because of the smaller pixel size for the XY resolution, the smaller XY resolution, which is technically more accurate, we have a smoother surface quality. And so when we're looking at precision on a machine, the XY resolution is really where you want to focus in at. As that number is smaller, it actually means that it's more precise. So it's higher in resolution. An easy way to think about this is to, take a look at television screens, for example. And so if you remember 1080p television screens when they came out, it was a big hurrah because they were so great and had offered so much detail. And then a couple months later, the 4K resolution screens came out and they offered even greater detail yet on the image that's being shown. The same theory kind of applies for 3D printing. That 4K screen versus a 1080 screen, the actual pixel size that creates each individual image is significantly smaller on the 4K screen, which allows it to offer a more detailed or unique projection of what the projection is supposed to be. And so that's a simple kind of way of thinking about it. All right, question number 5. In a sea of closed material 3D printers, why is Asiga open to third-party resins? And so I actually surprisingly get this question quite a bit because there's so many closed material systems out there, and it makes sense for a closed system. And the reason why closed material partners or closed material 3D printers are closed is because they want to have that return revenue on a resin itself. It's kind of like the razor blade and razor technique or business model. We don't find that right though. As a 3D printer manufacturer, the reason why we are completely open is because we believe that you deserve complete freedom. And why I say that, I mean, I want our users to have the ability to choose what material is perfect for their patient that they have in the chair with them today. Or with the practice that you have, you may find that a particular material may be too harsh or may not be strong enough. That needs to be able to fit in that exact requirement. And with our system, you can find any material with just about any requirement, and it's going to work in our system. That's the ultimate reason why we are completely open. All right. So after the question of why are we open, what if there's a 3D print resin that isn't validated yet? What do I do then? So for question number 6, What do I do if I have a 3D print resin that isn't validated yet? It's actually fairly simple. We have two solutions for that. One, we have complete documentation that guides our users, you, how to go through and validate a material into your system. If you don't want to do the extra footwork, that's okay, we get it, it's work. We do offer a service where you can actually send us a bottle of material, and we'd be more than happy to go ahead and create the profile for that resin for you. And so there's no limitations on that. We don't charge for that. It's completely free. It just takes a little bit of time for us to create the profile for you. All right. So while we're still on the resin kick for questions, here's another question that we get pretty regularly. It says, I have heard that you need to recalibrate your machine when switching resins. Is that true? This is actually a false statement. And so there are some, I don't want to call them rumors, but we'll call them rumors, for example, that whenever you switch a material on our machine, you have to recalibrate the system. That's actually false, so not true in any way. If you want to switch the material on our machine, it's fairly simple. You'll simply unlock the resin tray, remove the existing resin, and then place the new resin into the system and re-secure the tray down. It is that simple for switching materials. The only time that we recommend for recalibration is if it fails the calibration check process. And so we have a check process where you will validate to make sure that the build platform is parallel to the imaging plane below. If it fails that check, then calibration is necessary. All right. The next question we get pretty regularly is, how many models can I print with one bottle of resin? How much does it cost? And so instead of just covering dental models, I decided to cover a few different applications. And so this question it's kind of a generic question, but ultimately it all depends off of the size of the object itself and for how much resin it's going to consume per application. Now I do have like an average, and so when we look at this number, here's an average of how many applications you can get out of a per kilogram of material. And so, for example, for dental models, for full arch dental models, you can get about 40 to 50 per kilogram. And that's going to cost you about $2 to $3 to print. For splints, it's about 80 to 100 splints per kilogram. That's roughly $4 to $5 each. Now, once again, that depends off of the thickness of the splint. So if you are printing bulkier, thicker splints, you may have a reduction in that number and the cost per part will increase, of course. Denture bases, 40 to 50 denture bases per kilogram, and depending on the material, it can cost as little as $10 per denture base, all the way up to $25. For denture teeth, it's going to be 100 plus arches per kilogram, and that's about $2 to $5 per arch, of course, depending on the material. For all on X indications, it's about 90 to 100 per kilogram, and that's about $5 to $6 per arch. For single crowns, so single posterior, it almost feels like it's limitless. It's going to be 500 plus crowns per bottle of like temporary material or permanent material, and that's going to cost about $1 each to print. Now, something about the crowns and posterior crowns or permanent crowns, I've read that there is I guess a regulation changing where ceramic hybrid materials coming in January 1st of 2023, I believe it is, if it is 3D printed with a material that has greater than 50% of that filler hybrid material, it can be billable for insurance. So that's something to look forward to in the future. As that becomes available, I'm sure the different material manufacturers will start publishing if their material meets that criteria or not. Just something to look forward to for the future. Surgical guides, once again, depending on the size and the number of, I guess, stents per application, you're looking about 60 to 80 surgical guides, about $3 to $4 each. And then RPD, so removable partial denture frames, about 100 per kilogram, and that's about $1 each. So those are fairly low cost per item. So this is just a great way to see how quick you can actually make money off of your 3D printer. All right. So next question we get quite a bit as well It says, I have an Asiga 3D printer, but which curing unit do I need? And so this ultimately comes down to the material you're using and specifically reading the instructions for use. If you're like me, as soon as you get a new bottle of resin, you immediately open it up, you pour it in the tray, you start printing with it, and then you usually have this little pamphlet called the instructions for use, and you immediately throw it in the trash. I'm guilty of that. I think we all are. And so if that does happen, go ahead and go online for that material manufacturer and read through it, because it's going to state which curing unit is validated for that material and what the exposure times are needed, or the cure times that are needed, to ensure that the material meets the biocompatibility or material property or physical property standards. And so this question, it all depends on the material, on what you're using. And so some curing units are going to, or some resins are going to require different curing units versus others. And so that's something to check in and read on as you're exploring new materials. For non-biocompatible materials, you do have a little bit more freedom. You can use just about any curing unit because it's not going into the patient's oral cavity. However, for anything that's going into the patient's oral cavity, it is crucial that you follow the IFU and cure with the proper pros curing unit for patient safety. All right. So another question that we have, and I think I actually have 11 questions, and so I went above and beyond today. So I think we have one more question after this. And so this question is, does your nesting software have any fees? And so for the Asiga nesting software, which is called Composer, it's actually completely free to use. We don't charge any fees. There's unlimited software installations and unlimited software updates. And so it's a completely free platform, once again, giving you, a user, complete freedom without any sort of restrictions. All right. And so here's the final question. With so many 3D printer manufacturers in the market, why should I buy Asiga? And so this question is probably the most popular question, probably my favorite to answer. And the reason being, or why you should buy Asiga versus our competitors, is we give you the resource to have complete freedom, and we're future-proofing your system or your laboratory or your clinic. And when I say that, it's with this material freedom itself, you are able to select any material that comes out in the future and in the past itself. And so as the chemistry changes throughout the career of dental 3D printing, we're going to see that more and more unique chemistries are here, which is just going to unlock more and more applications. In majority of the material manufacturers, they're starting with an Asiga system first above anybody else. And so that means your machine will most likely receive the new materials first, and you're going to be able to use future materials without really any hesitation. The next reasons why you should buy an Asiga versus our competitors, we offer lifetime technical support for free for our equipment, and that's pretty revolutionary. And the fact that we have 3 locations across the world, with a Germany technical office, the United States technical office, and then our main office in Australia, we actually offer about 24-hour technical support. And so that's pretty amazing. Those are just 2 simple, I guess, reasons on why buying Asiga, of course, with all the other questions we had previously. So that concluded my 10 questions that are most frequently asked, and hopefully will help you in your purchasing decision and moving down the road. Or if you have an Asiga already, hopefully that'll help answer some questions that you may have had in the past.